Okay, let me continue the notes. Okay, so okay, if my polynomial p of x is equal to a naught plus a1x plus a2x squared up to an xn, then for any given xi yi data, okay, to find the polynomial of degree n, it should satisfy the form this one. So if I put in that polynomial xi, okay, let's say my is a degree of n less than or equal to 1. Okay, this is my polynomial. So when if I wanted to find the points, anything, okay, xi, so I can substitute this one. So a naught plus a1 xi plus a2 xi square. Wherever the x, I'm substituting xi. Okay, whatever the points. So this will be our yi points. Okay. So these are since 0, starting 0, ending 1. For example, let's say my x equal to 0, 1, 2, 3. Okay, how many points are there? Even though my n is equal to 3 now here. Okay, sorry about that. Can you hear me? There's a power cut. I'm using a hotspot. Anyway, I don't know how much. Can you hear me? Answer me, please. Can you hear me or not?
Yes, sir.
Okay, thank you. So I'll use some time for hotspot. Anyway, we'll wait for the power to come. Okay. So this is what I told you. This is our px in the form of polynomial. Okay. Then if you substitute x equal to xi, you can find whatever the values, isn't it? So here, as I said, x equal say 1, 2, 3. Okay, how many points are there? Here my n is equal to 3 now. But how many points? 1, 2, 3, 4, isn't it? So it's a 4. It's like n plus 1 points. So whichever the number if you are starting from 0, okay. So if you are ending 3, there are n plus 1 points. Similarly, if you are getting n points, so you should have n plus 1 points there. Okay. And also, okay, we can see later this one. Okay, in the example we can see. So when you are solving, let's say I have n points, but sorry, n plus 1 points will be there. So if I substitute that n plus 1 point, okay, our purpose is to find the a naught, a1, a2, you know, these coefficients. Okay, we call this as a coefficients. Okay, sorry, coefficients. Okay, so if you can find a naught, a1, a2, an, you can find the polynomial. No, so we have n plus 1 points. So if you substitute, you will have n plus 1 equations. Okay, so if you have n plus 1 points, equations, you can solve and find the a naught, a1, a2. That's the only thing we don't know. No, we have to find out. Okay, in this process. Okay, or n plus 1 unknowns of this one we can find. Okay, substituting the values of x equal to xi. Okay, so that's what this note says. So please write down this and I will give you one example. Let me. Okay, let's do one example, the same example, okay? So it's like I gave you x and y, 0, 1, 2, 3. We have the points of 1, 3, 9, 27. Let's see this one again, okay? So as you already said from your, earlier knowledges, you have found one of the y is equal to f of x, which is equal to 3 to the power x, okay? I also gave you one of the, polynomial anyway. Let's write down first of all in the polynomial way, the same equation, okay? So how we can find the polynomial using the values of this, okay? Yeah, so first of all, please write down the example again, okay? So let y is equal to p of x, we are equating to the one of the polynomial, okay? Degree of least degree. For example, we have here, 3, okay? 0 up to 3. So I need to go up to a naught plus a1. If it is px equal to n points, I go up to, n plus 1 points, I go up to an, okay? So a1x plus a2x squared up to an xn. This is our polynomial, okay? We're going to find out these coefficient for this example, okay? So how we can find? Like what I said, x equal to xi, okay? You can have n plus 1 n unknown, n plus 1 equations with n plus 1 unknowns, okay? Then solving that we can find. For example, let's say, let me put x equal to 0, okay? So what is p0? Similarly, x equal to 1. What is p1? Can you answer this question and find out the final output of px? Okay. If you find a0, a1, a2, an, that's all. You just substitute here in this equation number 1, isn't it? That's our here answer. Okay. Can you do that? You have to go 0, 1, 2, 3. Okay. X equal to 3. X equal to 2. So I'm expecting you to do the answers and send me whatever you are getting answers. Okay. Like for example, what is P0? What is P1? So step by step, you just send me the answer as well as you can continue. So what is the P0? I'm expecting the answer from you. One by one, send me the answer as well. Okay. Only 83 are there. Where's the others? Okay. Yeah, good. As well as the answer. Not only the, coefficient. You have the answers now. So what is x0 is equal then? If it is a0, what is the answer? Here. The value of from the table, you can find the value now. Then only you can solve it. A0 is equal what? Yes, everyone find A0. It is A0. Because what is our condition actually? Yi is equal to Pxi, no? So if you are substituting x equal to 0, that is equal to whatever the y naught. So what is a y naught? Yes, this is a naught. What is a y naught? It's equal to 1, isn't it? So likewise, can you solve these? Yeah. Sum of AI. Don't write sum of AI. Just find out there. All the values are there, no? At the 0, 1. At the 1, 3. So just write down what is the next step. If you know A naught, in this next next one, you may have A naught plus A1 something. So you substitute A naught again, find out the other coefficients. Like that only you have to, yeah. It may take some time anyway, but yeah, let's see how quick you are doing the, these are just school kind of questions, no? Solving the, system of equations. Just multiply the equation by 2 or 3 and take out all those process. For example, if you have 2x plus y is equal to 3, x minus 3y is equal to 5, how to solve it? It's a simple thing, no? You can multiply this one by 2 and subtract, and you can find the y, then substitute the y in the equation number 1x. That's kind of, process here. So I need you to, finally answer me what is P naught, P1 up to P3, as well as the final polynomial Px. So this is your target now. Can you send the answer of P1, first of all? Okay, good. Is that P1? Check your answer, 73. You don't need to go up to AN, no? 094. So in this example, we have up to A3 only. So you don't need to go up to AN, isn't it? So according to the questions, we have to cut down the polynomial values. Okay. So generally it is going up to AN, but according to the question, we can cut the, whatever the x values, how many x values, you can cut down the coefficients. You don't need to go up to AN for every time. So for example, in our polynomial, if it is Pn, we have A1, A0, A1x, up to you have to go ANXN. Okay. But if it is only 3, so you can cut down wherever the 3, A0 plus A1x plus A2x squared plus A3x3. That's all we have here. Okay. So you don't need to go to the rest. Rest will be 0. Okay, no need to consider. So you can cut down this up to here. Okay. So what do you think? Anyone find the A1? At least one person? Yeah. So it is something, yes, I know it is some kind of calculation there, but no, can you check 132, 77? You may made some mistake. Can you check? I don't know whether my answers are correct or not, but see whether my answer is correct or not. A1, they say 8 by 3, A2, 2, A3, 4 by 3. Is that correct? In any of, maybe it's wrong. Please check your answers. Maybe this is correct or wrong. I don't know, but check your answers. Something like this only you will get. Wait. Should be correct some way. Check, you may make some mistake, or either I may also make some mistakes. Okay, I hope you got the idea, so I don't need to waste time here. So after, do it again and find whether these answers are correct or not. And after that, you can write our polynomial in the way like this: 1 plus 8 by 3. If it is my answer correct, is that minus 2? Check the answer. Is that minus 2 or plus 2? I don't know. Again, check the answer. It says minus 2 or plus 2 something. I don't know. Maybe plus 2x squared plus 4 by 3 x cubed. Something like that. So whatever you find, A0, A1, A2, A3. Okay. So this is not P1, no? P1 is you substituting. So A0, sorry, yeah. A0 plus A1 plus A2 plus A3 is equal to 8. Sorry, 8 or 3. 3 is our P1. Okay. Likewise, P2, P3. After that, you do some calculations to get the A1, A2, A3. I don't know whether these answers are correct. After you finding, you just substitute the coefficient in our equation number 1. That means Px equal to A0 plus A1x plus A2x squared plus A3x3. This one. Okay. So if you substitute, this will be our final output. Okay. Please take some time to check these answers. I need to continue the lectures. Okay. Okay. Let me continue the notes first of all. Okay. So there is a theorem, of course. Okay. That's how we have derived our, definitions. Okay. It's nothing, new. Just the definition. Okay. This definition has been derived from this theorem. The theorem says the problem is well posed. Okay. It means it has a unique solution. Okay. For the given set of data xi, yi, I is equal to 1, 0 up to n. Okay. Then you can find there exists a unique polynomial. Okay. So if it is a well posed, problem for this data set, you should have a unique. Okay. There exists a unique. Okay. This polynomial will be same for all. Even if we are 103 people are solving this one question, if using this interpolation method, okay, you should have the same polynomial. Okay, you can't have different answer, or it should be the same. Okay, that's what they say. There is a unique polynomial Pnx of degree that's no equal to the n, such that this one we already have seen this It's our interpolation condition. Okay, yi is equal to Pn of xi. Some people use Pn, some people just use Pn is good. Okay, it means the polynomial of degree less than or equal to n. Okay, so it means it goes up to a naught to an. Okay, so this polynomial Pn of xi, okay, whichever the discrete point of xi you are substituting, okay, you can get the interpolation polynomial of that point. Okay, so for any point between the interval I, we can find from this interpolation polynomial. So that is the theorem says. Okay, so yeah, if you can write down or take the screenshot. So anyway, I will try to send, but not sure. Okay. So from this theorem only, we have defined our definitions. Okay. Now we are moving to the possible methods to find this polynomial. Okay. The earlier one, but we have substituted and find, it is a normal way of finding the polynomial. Okay. So if they give some xi, some yi, finding the pxi, it's kind of method. Okay. Likewise, we're gonna find some more methods. Okay, which will give you the interpolation polynomials. Okay. So I didn't type any notes for that, but I will explain you anyway. Okay. So just put the heading interpolation methods. Okay. Okay. First of all, don't write these things. I will give you later. I will give you some idea that first of all. Okay. So so you can see we have so many methods anyway. For time being, we will study here some methods. Okay, that method will become for your exam. So if you're interested, you can study other methods as well. Okay. So interpolation method, we're gonna divide in two cases, like a normal one. Okay, it's not a defined one. I'm just dividing. Okay, this is kind of a inverse. Okay, there is a method also. They are inversely find the interpolation. We can study later. Okay, in the normal sense, we will have two branches. Okay, as I said you for equal interval. Okay, so what do you mean by equal intervals? Similarly, unequal. Okay. So according to that, they have different methods anyway. But yeah, we can totally see in our section course. So what do you mean by equal interval means? Is that talking about the y or x? Can you answer me? So in the sense of for equal interval, the unequal interval, what they are meaning? Whether the y values or x values? I think I already explained you. I just need your answers. Yeah, get the power. Anyway, so here's the answers. Whether it is talking about the y or x. There's the answers. Only one person answered them. Okay. What's happening? Only one or two people are answering. Where's the others? Do I need to call your numbers? Yes, of course it is x, no? Y is not in our hand. It is depend on the function, no? So it is talking about the x values. For example, if you have, let's say 0, 5, 10, 15, 20, something like, we have the common differences. As I said to you, common differences, okay? The differences are common, equal, okay? So there are situation unequal. Also, I have told you, like for example, 1, 5, 18, different intervals. This has some method, this has some methods, okay? So in that sense also, we're gonna study in a different way. So also in the inverses or for unequal only, okay? Inverse is for unequal, so you can this one and this one we can study totally, okay? This one is little bit easy, I guess, okay? We already studied also, so no problem. So this is something we're gonna study, okay? What are the possible methods, okay? Under this one, we're gonna study our Newton's forward as well as Newton's backward methods, okay? Interpolation formula. So still again, the Newton's forward backward difference is gonna come again. So in this unequal, we're gonna study something we call Lagrange's formula, okay? So this is also this one, and this one inverse we call Lagrange inverse interpolations, okay? So in this we're gonna study Lagrange's. So after we study Lagrange's, we can see the inverse Lagrange's interpolation formula, okay? So this is our planning for this chapter, okay? So you can see one by one. We have what's the time? We have 10 minutes only. So anyway, I will start some methods, okay? So we can continue from next week also. Okay, first of all, so these are already I have explained you today as well as last class also. So it is very easy for me to teach you this for equal interval methods, okay? So as I said, for the forward, we use delta. As backward, we use nebula, okay? So that's that. Okay. I will send the notes anyway, some notes, okay? I didn't type yet, but I will try my best anyhow. So just I will explain for I have 10 minutes. No need to write anything, just write whatever I'm writing here, okay? Some methods, okay? So let's say, first of all, let's see what is finite difference. I already explained you, okay? If f is a function, okay, of x, that is we called y, okay? It's depend on the independent variable of x, okay? In the domain, let's say interval a comma b, okay? This is a minimum point, this is a maximum point, okay? For each value of x in the given interval, we can find the fx, okay? So the value of y can be determined just by substitution, okay? So according for yi, we can substitute xi and in the function, then we can find the yi. So this is our process to find a finite difference, okay? So the method to find this kind of values based on this principle of finite difference, we called as a we're going to use this this method in our interpolation techniques, okay? So this where this function should be a continuous function, so that is one of the conditions should be satisfied, okay? Always the function we are taking for this finite difference is a continuous functions, okay? Okay, so forward differences, as you can see, as I already told you, delta of fx can be either we can write in the form of x plus I h minus f of x. Or if you are writing in terms of y, you can use, if it is n, you have to write yn plus 1 minus yn. Okay. So what do you think? Delta squared. Okay, let me continue in the next page. So if it is delta f of x equal to f of x plus h minus f of x. Okay. So let's see what is the second delta. So as I told you in our last lecture, so delta times, I can take delta inside, no? Like delta times delta fx. That's what happened here. So it is like is equal to, for this one, I can substitute this one. Okay. So like just write down whatever I'm writing just for your explanation. Okay. So this is what is equal to delta f of x plus h minus delta f of x. So you have to know. So the second difference can be found from the first difference. Okay. 2 points from the first difference. Similarly, you can construct for delta 3 f of x. Okay, this can be written as f. You can find like this. I mean delta squared f of x. Okay, so write down this one. So final will be delta squared of f of x plus h minus delta squared of f of x. So you have to know this term can be found by the one term less difference. Okay. Likewise, delta n f of x can be written as delta to the power n minus 1 of f of x plus h minus delta to the power n minus 1 of f of x. Okay. This is our forward finite difference. Okay. Okay. So as like how we can solve some questions. Okay. So I think one of the question I already included in the homework quiz also. You can solve that question using this knowledge also. Okay. So they say, for example, let's say x equal and y is equal something else. Okay. For example, give me a second. Let's say some, maybe anything like, okay, equal values 15, 20, 25, 30. Okay. So they are giving some unimaginary numbers like, see, like these numbers. So it may seems like big thing, but not actually. Okay. Yeah, something like 9063. It's you do this one also. Okay, write down this example for the under the forward difference. Okay, so you know how to solve this one using our forward difference table. Okay, forward difference table. You have to put. I'm not gonna teach you anyway. You put like y, and next one will be delta y. You have to take the difference of this one. Okay, you know this delta y will be this is y0, this is y1, let's say. So delta y, since a forward difference, this is equal to y1 minus y0, no. Similarly, it continues. Okay, then if you want delta squared y, you have to take these two. Okay, let's say this is my delta. So y0 or y1. If it is forward, if it is delta yn, what will be this one? Give me the equation of delta yn for the forward difference. I already gave you here, no? So y1 minus y0, no? So here, what is the delta? Delta of yeah, that's correct. But I'm asking delta of what? So delta yn will be yn plus 1 minus yn. See, one term bigger and this less than that same value. Okay. Likewise, so this will be, so this value, no? So 0 means here 0. So next one will be y of 1, delta of y of 2. So if you wanted to find delta squared of y naught, which is equal to delta of y1 minus delta of y naught. Okay. So that's why you will find. Again, delta q1. So until how much you have to go? Until you get all are same value. For example, do this question again. Okay. If you do that in some point, for example, let's say in the delta of 5, okay, in the delta of 5 you will get only one value. Okay, so it will be strung like this. Okay, something it will go like this. Okay, so everything will be come into only one value. Okay, so after that, okay, after you made some forward difference table, you find out delta squared of y of 10. So what is the question is, I will go to the next window. Okay, so what is that says is, we know this is x naught value, x1 value, so x2. So when you are writing also, you write down the perfect values also. Okay, this is my yn, sorry, xn, this is my yn. Next one, I'm gonna go this way. So this will be delta y naught, isn't it? Okay. Okay, so this is delta y naught. Next one, delta y1. Next one, delta y2. So you find the answer this one like this. After you putting like this only, you find the answer like that. Okay, so this will be easy for you to answer the questions in the exam also. Okay, here you have to go between this one, no difference. So what will be the delta square y of naught? If it is a forward one, you have to know these are the things. Y naught, delta squared y naught. So delta cube y naught. That's how it will go. Okay, let's say this is my last one, fourth one. Okay. Then if they say to find you delta squared of y of 10. So the question is this one. I will send the question anyway. Okay, let's say this is my question. They asked you to, from the table, they asked you to find this one. How possible I can find? For example, this one, let's say this one 5, this one 10, no. So in this point only, this will be y of 10. Okay, so I need to know x equal to 10 is the index is what? Index is 0, 1, 2,